Hello everyone. In this tutorial I am going to explain how can we manage the distributed transaction using two-phase commit approach. So first of all we need to understand why we are going to implement two-phase commit approach, right? So if we take one example, an e-commerce example basically for purchasing something from e-commerce website. So there actually basically any user can like place an order. So we can say the order is basically placed successfully if the payment details is done successfully. There is the inventory system. So if the inventory is done successfully, delivery place means order kind of thing, address kind of things, all the things are done successfully, then we can say the order is placed successfully. Otherwise it will be not placed successfully. We need to roll back the everything in case of the anything is failed in between. So it's look like very simple, right? Because in a monolith applications thus it will be very easy to handle those things. The entire workflow can be considered as a single transaction, so that's why it will be very easy to commit or roll back when everything it will be in a single database, isn't it? But if we think the same situation with distributed systems with multiple database, it will be going to be very complex. Why it will be complex? Because for this situation actually we need to create multiple microservice based on the module and each microservice having separate database. So when this situation will arise, then it will be very difficult to manage transactions. So it will be called like something like distributed transaction. So to solve the above discussed problem, whatever I am discussing over here, so that in this particular scenario we need to call the rollback method from where it is calling. For example, we are having two microservices. One is the order and another one is like payment microservice. So if the order is successfully done but payment is not done successfully, so from the payment service actually basically we need to call the order rollback service. So let's check this diagram basically. So as like if we are discussing this particular order place kind of project actually in a single DB kind of thing in a monolith application, so if we break those things, so we can like just for the timing I've created two microservices. So one is the order microservice and another one is the payment microservice, and as you can see these two microservices having the separate database call. So when any client giving any like any request will come from over here in order service, so let's say like order is saved is done successfully over here in this database. Now the payment will be go. Now in the payment service somehow it will caught exceptions. Now what you'll do, that means payment is not successfully done, so that means we need to call the rollback from over here. Then actually it will be sync up those transactions, else there is a data inconsistence, means data will be not consistent, right? So for managing, so this is a kind of the problem actually. So this kind of problem can be means widely used in the architecture to solve these issues actually. So one is the like two-phase commit approach and another one is the saga design pattern. So the saga design pattern basically I've already like explained in my one of my videos, so I will share those link in the description sections. Today I am going to explain how we are going to manage the distributed transaction using two-phase commit approach actually. So actually as you see like the name conveys, actually the two-phase commit protocol actually breaks a database commit into two phases into a distributed database system. These phases basically are, the first one is the like prepare phase and the second one is the like commit phase. In the prepare phase actually all the involves means whatever the services are involved are asked to prepare for a transaction. Once all the services are acknowledged the regarding the preparations of the data or kind of things, then actually the transaction is happened. If any service responds with a negative acknowledgement in case of maybe internal error or any kind of the failed or any kind of anything exception occur, then the transaction is aborted globally and it will be rolled back or it will not do any kind of things over there. So to achieve this actually things like this kind of prepare and then commit, actually one kind of the transaction coordinator is required which manages the entire transaction life cycle. It issues the prepare commands to individual microservices and listens to their response. So let's check the like a diagram of this one. So this is a kind of diagram of this two-phase commit design pattern. Like as I was saying, there's one kind of the coordinator service is required, which is basically coordinating all the services, microservices related to the placing the order. So from for me actually, just to demonstrating this one, I've created two microservices. One is the order, another one is the payment. Okay. So from the coordinator actually initially it will like they will call for the prepare services. So it will call this order service, then payment service. Once they will get the all the PPR is success, then they will commit the order service and commit the payment, and then it will give us the response like all the things are done successfully. In between, like if the payment is failed, then it will actually basically roll back the order. If there is a multiple services also involved, then the same approach will be going for those things also. So this is a like overall, as you can see from this clients actually basically any request, whatever the request will means we need to provide for the order related. From here it will come to the coordinator service, and this particular coordinator service actually basically responsible to talk with the some other services, like as in the picture is depicted here, like in the order microservice also, and same for the payment service. So what we are discussing about the architecture of the two-phase diagram. So it's having the two things basically. The first phase is the like prepare the data, and the second is the commit the things. For the prepare, if in between is something is failed, then it will actually basically roll back the all the things. So the data like there is a no data error actually basically. So this is like overall the diagram of this two-phase commit design pattern. Now what we will go what we will do the next, actually in the next we will create one the same, we will create the three microservices. One is like coordinator microservice, then order and the payment, and we will do the like transaction, like how this two-phase commit basically work in a real scenarios, like in a real coding. So I am going to be create those services, and accordingly I'll give the demo accordingly. Let's create those project. So for demo purpose I have created three Maven based project, as I was showing in the architecture of the two-phase commit diagram. One is the coordinator service, another one is like order service, and the third one is the payment service. So if we look through the dependencies, what are the dependencies basically we need to require for this one? Like one is for the starter data JPA, as there is a kind of database involvement is there, because we are going to integrate, like we are going to save some data into the database, so that's why it's needed. Then like starter web, as we are going to create the controller for this one. This is for the development perspective. As a database, we are going to use the H2 in-memory database over here, but in a real time basically we are going to use the maybe MySQL, Oracle or Postgre, anything. Lombok and the starter test. So this find so these are the like main dependencies basically we are going to was here. For coordinator service, basically for this we don't need any kind of the H2 database, so that's why this particular dependencies is not required over here. So let's create, means as you know, like this kind of project you guys can create from Spring Boot, Spring Initializer website. From there you guys can like choose the dependencies, what dependencies you need to choose, and also with that also you guys can like select the what are the artifact ID and the like group ID. So those kind of things you can choose, so it will give all the ready-made project. Okay, so let's means create first from the order services. So what you need basically in the order service, basically it will accept one request, and based on that it will actually prepare the order, and another microservice will be, another API will be like actually basically three APIs we need to create. One is the prepare, another is the commit, and another is the rollback. So prepare will be like just prepare the data and means save the data into the order data order means table actually. Commit is responsible to update the status of the particular order, because in prepare actually you are like save the data as a preparing status, and in the commit actually basically from preparing to we can update as a completed. If it is rollback, then we are updating the, we can update the status as rollback. Okay, so let's first create the controller service over here, one package first, like dot controller. Over here we are going to create one class, for example order controller. Okay, okay, it will be obviously a REST controller. Next, here actually we are going to create 3 APIs. Okay, and here actually basically we are going to create one DTO basically, which is basically request of any request actually that actually request coming from the postman or either any client. So let's create this particular DTO. It's called maybe transaction data. Okay, and it will having like 4 fields like order number, item, price, and the payment mode. And here we are providing the getter and setter. Okay, so this is done now. Next, basically in a controller, basically we are going to create one API which is basically responsible to prepare the order. Okay, now here actually are going to, what we will do over here, we will we are going to create, and here tell to new order. It will be a like database entity, so that entity also we need to create, like need to first create the order DTO, new class, and it will be a order, and the table name order underscore details, like this. Okay, and it will having the like 4 fields like this: ID, order number, item, and the preparation status. Okay, like the status can be whatever the like it's a prepared or maybe rollback or kind of completed. Okay, okay, need to import this one. So that means this entity also done. Now here, okay, here actually we are going to provide the catch, and directly you can write the exception, then E. Okay, so from over here we are going to return, if it is from exception also, then we are going to return like response entity dot status. From here we are going to http status this enum dot internal server error, and in a body actually we are going to pass error during order preparation. Okay, okay, and here actually we are going to set the data like order number, order item, and the transaction status. Okay, this item, okay, we need to create this enum one, order preparation status. Okay, and here basically we are going to keeping these fields like not prepared, preparing, committed, and the rollback. Okay, this initially it will be preparing, then committed, and the final means if it is any rollback happen, then in that time we are going to mark it as a rollback. Okay. Now once the data preparation is done for this one, then we are going to save this particular data into the database. So for saving the data into the database, we need to create one repository, right? So that for that we need to create one interface. So let's say it's a order repository. Okay, and we need to extends JPA repository. Okay, and here it will be a order and the ID will be a long. Okay, so this is done now. Okay, now here we need to auto add this one. Okay, private order repository. Okay, so here dot save order. Okay, so now the data save is done now. So here what we'll do, we will get one request. This request will get over here, and then we are like setting the data into the order entity, and accordingly we are saving the data into the database. Now, so that means the data preparation is done now. If something is getting failed, then we need to return runtime exception. Okay, so means something like if false or maybe true, then we are going to return this one. So for that actually basically we are going to, and okay, before that if it is not true, then what will return? Will return response entity dot okay, and here we can say order prepared successfully. Okay, so this is done now. Now here actually we are going to create another method which will basically return the like boolean should failed during prepare. Okay, for the time being it will return false. Okay, and this particular method we are going to use over here. Okay, so that means prepare order method is done now. Okay, next what method we are going to done here, like for the commit. In the commit, what we are going to do over here, we are going to like save the data, means we are going to update the status. So for that we need to first actually like fetch the data from the like in this repository, means based on the order, means whatever the order means in the prepare actually, suppose we have saved the order details, okay, with preparing status. Now what we are going to do in the commit actually, we are going to save the data, means we are just going to update the status of this particular order table, means from the preparing it will be a completed or committed. Okay, so for that we need to find out this item. So from this order repository we need to find out, like find by item. Okay, and here actually from this DTO we are going to get item. Okay, so this method basically we need to create here, and it will automatically like fetch the data, because this method we have defining over here. Okay, now it will be a order. Okay, Now this is done. Now next actually we'll check if order not equals to null, or not or actually basically, and order dot get preparation status dot equal ignore case order preparation status dot preparing dot name. If this is also match, then we can set the order dot set preparing status. We need to set data with the preparing status order dot committed. Okay, committed dot name. Okay, status is done. Now it is to order. Okay, next we are going to save the data into the database. That means dot save with order. Okay, now that means if it is saved done successfully, then we can say order committed successfully from over here, right? Now if not, if it is not, then we can say order cannot be committed. Like outside of the if, we can say like order cannot be committed. So this is like commit. For the commit actually basically we are going to do in this way, and the next basically we are going to roll back the order. Okay, so here what we will do, we will actually basically update the status as rollback. So we'll also follow the same approach. Okay, basically I'm copying this one, and like find the items, we are not checking this one. So here instead of the committed, it will be a rollback. Okay, order rollback successfully instead of the committed, and error during rollback. Okay, so this is overall things for this order controller. So in the order actually done, and in the resource in the properties file, as you can see, the port of this one order service is 8081, and the h2 database like the database name is ordersdb. So this is like means for the order is done. Now next we are going to create the code for write the code for the payment microservice. So let's create the code for payment microservice. So once actually we are able to, means we can write all the code for all the microservices, then only we can like we will start the each microservices, and we can like do the testing from the postman. So let's create the code for this payment microservice. For creating the payment microservice also we need to follow the same approach. Like as we have created the 3 APIs for order microservices, like one is the prepare order, then commit, and the rollback. The same approach actually we need to follow, and the same data is also required. So let's create the new package for creating the controller and other things, like dot controller. For the time being, or maybe for the demo purpose, I am keeping all the things in a single place, but in a real project it will be a different one, and I am just copying all the things because it will be more or less all the things are same, only little bit of differences over there. So I am keeping the same things over here. Okay, so instead of the order actually entity, we are going to rename this entity as a payment. Okay, and in the payment actually the field name will be different little bit of it, like ID is there, order number also there, and item also there, preparation status also there. Only I'm going to add these two new fields. One is the payment mode and another one is the like price. So this is the payment mode and this is the price. Like payment mode, like it's a online, credit card, debit card, what kind of it is. So that the payment mode we are going to store into the database. And instead of order details, we don't need to mention anything. It will be default, will be like create as a payment. So okay, so first is the ID, then order number we are storing, item, then preparation status, and then payment mode and price. Okay, all are fine now. Next, instead of the order preparation status, we are going to like the maybe payment status. Okay, payment status, and the like value will be different little bit of it, like pending, approved, declined, cancelled, rollback. Okay, so instead of that, this will be I'm keeping. Okay, so payment status also done now. Next, in the payment repository, it will, instead of the order, it will be a payment. Okay, payment repository, and the repository having the same name. For the timing I'm keeping as the same. Okay, if it is record something else, then we can add over there. And next, in the last, actually we are going to rename this controller, like it will be a payment controller. Okay, okay, now so here actually in the payment controller, instead of order, it will be a prepare payment. Same for like commit payment, and in the rollback, instead of order, it will be a payment. Okay, so this is done now. Next, what we will do, it will be a fine. Then here actually order number, preparing status, we are going to, instead of this, it will be a pending. So initially, like in the preparation mode, it will be a like kind of pending actually. Once it will be approved, then on the same time will be as a approved. Next, price, set price, we'll save the price from here. We'll get the data from this DTO, from this request. Okay, anything else that we are missing? Order number is done, preparation status is done, payment mode. Okay, order dot payment mode, set payment mode. So payment mode also will get from the request dot get payment mode. Okay, so order number we have created, preparation status is done, item is done, price is done, payment mode also done. We are also saving the data. Okay, instead of the order repository, it will be a payment repository. We need to rename it. Okay, okay, so this is done now. Next, like if it is failed, then we are saying payment preparations for payment. Okay, payment, else we are saying payment prepared successfully. Here also error occurred while during payment preparation. Okay, so that means prepare payment is done. because it is similar kind of the order kind of things. There is a nothing like difference, only you are just saving the data into the payment table with pending status. Okay, instead of order you can say it's a payment. Okay, so this is done now. Next phase in we'll doing like commit one. So here it will be the same, and we are checking with pending. If it is a pending one, then we are updating as a approved. Okay, so here you can say payment committed successfully, payment rollback successfully, payment committed successfully, payment cannot be committed, error during payment rollback. Okay, so commit is done now, and for this rollback, okay, this is also done now. Okay, so that means payment is ready now. So what we did for the, this is also similar kind of thing. Here we are also created three like KPIs. One is the prepare payment, another one commit payment, and the third one is the rollback payment. In the prepare one, we are just saving the data as a pending status. In a commit, we are updating from the pending to the approved, and in case of if it is a rollback, then we are going to roll back the data. Okay, so okay, it will be our, in case of the rollback, we are going to not bad request, actually it will be an internal server error. Okay, it will be an internal server error. Need to check for the order controller also. Yes, it will be an internal server error. Okay, so payment is done now. Next, like we'll create, okay, one more point over here, just check for the, like here the port we are keeping as 8082 because for the order is 8081, and for the payment is 8082, and the database is the payments DB. Okay, next we'll create the coordinator service. So let's create this project. So let's create the coordinator services. So order and payment both are done now. So for the coordinator service, basically what it will do, it will basically like coordinate with order and the payment services. First it will actually create the like it will call the prepare phase, and then when the all the prepare phase is success, then like it will call the commit phase. Okay, so let's create the code for this one. So first we will create one package for this one, like for controller. Okay, so the name would be kind of coordinator controller, netter controller. Okay, provide as a request mapping, sorry, REST controller first. Okay, public string for the timing, just keeping as a response, initiate two-phase commit. Okay, it will take the input as this transaction data, taking as input. So here it will taking input as a request data, request body, transaction data. Okay, and it will be a post mapping, and here slash initiate underscore two-phase commit. Okay, so next basically we are going to create one method over here which will basically return boolean. What it will do, it will call prepare phase. Okay, and it will actually basically taking this transaction data as a input. Okay, so what it will do basically here, so for calling the external services we are going to use REST template. REST template equal to new REST template. Okay, so using this REST template we are going to call the services. Okay, create another class, call services. Okay, it will take the URL, so string URL comma transaction data, for example. Okay, so what it will do, it will actually basically REST template dot post for entity. So here basically we are passing this URL and then transaction data and what response we will get. So we are expecting the string response. Okay, so it will be a response of a string. Okay, next we need to return this response. Return response dot get status code dot is successful or not. Like it's provide one method is 200 is successful. Okay, so this call service method basically we are going to call from over here. So here actually we are going to pass this URL. So what will be the URL for order microservice? http://localhost. So order will be open in 8081/prepare_order. Okay, and same for we need to call for the payment. So prepare order and then prepare payment. Okay, so now we are going to check boolean is order success. Next we will check if payment is success. Okay, next we are going to return if both are true and is payment success. If both are true then it will return success. Okay, and if any exception is happened from over here, catch exception, then it will return false. Okay, now from here what we will do, we will call this particular method. If call prepare phase with this data, if it is a true, then what we will do next, we will call the commit phase. Next if means if it is success, then we are going to call the what you can say, we need to call the commit one. And if not success basically, so from here If it is a success, then from here we are going to return okay. Let's create another method which is basically do the commit one. Okay, it will be a similar of this one. Okay, call commit phase. Instead of the prepare, it will be a commit. It will be a commit. Okay, we don't need this one. If both are success, then it will be a success. Okay, and inside of this one, like if call commit phase, if it is success, then we can say return transaction committed successfully. Okay, else we need to, from here we need to call the rollback service. For that we need to write another service basically, which will basically do the rollback. Okay, call rollback. Okay, so in the rollback basically we are going to rollback. Okay, we are having this rollback one. So for this rollback we are going to call this service. Okay, okay, means here actually we don't need the any kind of status over here, so it will be a void. Okay, so if then from here, if it is commit is not done, then we are going to call the rollback. Okay, and from here return transaction rollback. Okay, and from here also we are going to call the rollback, right? And we can say we can return from over here that transaction basically where it's a rollback, because this is not success. If this is not success, then only it will come over here, right? So this is basically overall the things for this one. Okay, it will be 801 and then 8082. Same for this one also, because 8082 the payment service will run and 8081 order service will run, and in 880 port the coordinator service will run. Okay, so this is the kind of coordinator service. Now we'll start these services one by one, and then we'll try to hit this particular API from the postman. Okay, so let's try to run the applications one by one. Okay, so we need to start the program one by one. So let's run this program first. Next we can run this order one. All the services will be start in a different port. Like coordinator will start in 880, order service will start in 8081, and the payment service will start in 8082. Okay, So once it will start, then we can check the database. You can say orders db. Initially it will be empty. We can run this one, and here also it will be a payments db. Payments db. Okay, empty. Okay, so now all the services are started. Okay, so let's try to hit means trigger call this API actually, this initiate to PC. Okay, so what it will do, it will initially all the will be a success, means valid scenario. So let's purchase this one as a payment mode as online. So we are expecting the transaction will be success. Why it is rollback? Let's check. Order service, payment service. Okay, transaction rollback. Why it is failed? So rollback. Let's check why it is failed basically. Okay, it's a basically true. Okay, so that's why here it is a failed. So that's why it's rollback the transaction. Okay, so that means as you can see, means from the payment actually means order is success basically. From the order we are getting success, but from the payment actually basically is getting failed because we are throwing the runtime exception. So that's why it's rollback all the transaction, means it's rollback from the payments, also rollback from the order service also. So that's why it's rollback the data. So if we update from true to false, so that it will then success. Okay, let's say it will rerun again. Okay, so let's mobile, for example, 1. Now it will be a success, transaction committed successfully. Now check the data. So from the order details, you can see because order is not restarted, so as it is a in-memory database, so if the service are restarted, then automatically data will be flushed. But we have not restarted the order, so that's why we are keeping the previous also 1. So for the mobile one, as you can see, the data is committed. So here actually it will be restarted because as we have modified the code, so that's why it's restarted. Now if we run this one, so as you can see, the payment mode is online and payment is status is approved. So for the mobile one item, it's success, right? For the mobile one is success. Now if we roll back kind of scenario, when it will be fail, how we are going to fail. So if we are from here, if we are return the true, that means we are forcefully failing this one. Then we are from the payment microservice, we are returning the any exception. So in the if any exceptions from the payment is occurred, they need to roll back all the data. Now again we can revisit this one. Roll means retry the failure scenario. So that's why keeping as a so failed during PPR. So it's a true. Now try to okay. Let's check the database because payment again restarted. So that's why you are not getting any data over here. It will flush the data. We are not getting any data here, but it's a in-memory database, so it will keep all the data over here. So let's run with the mobile -2. It will be rollback. Now if we check the database, you can see the mobile 2 is rollback, and in a payment also you can see the mobile 2 is rollback. So this way actually the transaction is distributed, transaction is managing using two-phase commit approach, right? So this is the overall thing, how we are managing the transactions in a two-phase control, using the two-phase commit protocol. So this is the one of the thing. obviously it's having an advantage, like if even one service is getting failed to prepare, the whole transaction is aborted. Otherwise the whole transaction is success. As you can see over here, if in a payment service is getting like failed, then whole the transaction is aborted, right? Else if not any kind of the failure is occurred, then it will automatically transaction is getting success. So this ensure that the transactions globally are always atomic in nature. The chances of data corruptions are low. But the disadvantage of this two-phase committees, the biggest disadvantages of this one, that is block the resource for a long duration, right? So all the individual services need to keep a lock on their resources until the transaction is getting completed. Multiple involved microservices add to the increased time of the overall transactions, leading to long locks of the objects. So that's why only this is useful in certain scenarios and not recommended to use this otherwise, right? So this approach cannot be used basically in a high throughput kind of transaction system. Two-phase commit also needs kind of the separate one coordinator we have introduced, so that's why also we need to manage this one, and means we need to scale this one, and so it's the only means failure point of this one, right? This is the only responsible to handle all the time. So these are the disadvantages of this like two-phase commit protocols. So this is overall things of this two-phase commit, like how we are going to use this one in a distributed management system for managing the transactions. Also I have like explained the advantage and disadvantages of this one. So that's all about these things. If you guys have anything, please do let me know in the comment sections. Thanks for watching. Bye bye.